Hello everyone. So in this video, we'll be discussing about the incompleteness and inconsistency of the mathematical number theory that Godel's theorem proves. So theorem proves that Godel's okay, theorem proves that any mathematical theory will be either inconsistent or incomplete. That means any theory, if you're trying to make it complete, it is going to be inconsistent, and if you're trying to make it consistent, it will lead to incompleteness. Anyone definitely will be there. Okay, so we have to understand what is this inconsistency and what is this incompleteness. Okay, so let's go through one example. Let's take one example. If I say I am reading, okay, and reading is my hobby. So what is reading over here? Which part of speech, which figure of speech? And what is reading over here? Can I say this reading is a verb? I am reading. It's a verb, right? And this reading over here, it is acting as a gerund. The same word reading, okay? The same word reading in different context, it is giving you different meaning, right? Now let's take one more example. I'm not going to answer this one. God is one, okay? God is one. So what is one over here? Which part of speech? Which figure of speech? Any number quantity? So this is up to you, okay? So now coming back. So what do we see? In our ordinary language, we have grammar. Okay, so we have grammar. So same word can be used about the individual also and about universal also. Okay, any particular thing, or it can be used for denoting any universal thing. Okay, so grammar gives this facility. But there is no grammar in mathematics. Okay, there is no grammar in mathematics, and there should be there. Okay, so this incompleteness is arising because lack of grammar in mathematics. Because numbers or words can be used or can be used to denote about the individual also or about the universal also. Okay, so I just write okay that numbers much like words, numbers much like words can denote individual or particular, and it can be used for the universals. Okay, and there is no grammars, so we don't have that how to differentiate on this mode about this mode. Okay, so mathematics lacks grammar. Mathematics lacks grammar. Mm, God's theorem that talks about incompleteness and inconsistent It's only because there is no grammar in maths. That's inconsistent. Because if we keep the this incomplete, if we keep the modalities separate, okay, if we keep modalities separate, then we cannot prove or disprove the propositions. We cannot prove or disprove some propositions. But if there is any proposition that involves both modalities, okay, any propositions that involve both modalities, will give rise to contradiction. Okay, will give rise to contradiction. Right. So, what is the takeaway from this video? Talks that mathematics should have grammar just like we have in our ordinary language. Okay, so at that time, what will happen? The same word can be used to talk about the individuals or particular, and it will be used to talk about the universal or any concept. Okay, so what can be done? We should try to introduce grammar in our mathematics, or rather, we can try to mathematize our ordinary language. Well, it's not that easy to mathematize our ordinary language, but yes, once when we understand that the differences of ordinary language and mathematics, our ordinary language is complete. There is no doubt. We understand how the same word in different context how it is used. But for mathematics, we don't understand. So mathematics, although it appears very successful, it is actually incomplete. Okay, mathematics is incomplete. So we'll take pause over here. We'll continue in the next video. Thank you.